Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at SegMoE, diffusion mixture of expert by Segmind. So, in last few weeks, we have seen, n number of mixture of experts model, and the starting point was by Mixtral AI when they created Mixtral ATEC 7B model, where we saw how different experts model can work in tandem to solve some of the use cases with large language model and in generative AI in general. Now, recently we have seen there's an organization, there's a creator called Segmind. They have created Sig MoE, Sig Diffusion Mixture of Experts model, where this can help you generate, media like images, and you can create your own diffusion mixture of experts model using this framework. So Sig MoE is a framework that helps you create, diffusion MoEs, and we will see how we can inference this in our notebook, and how we can create our own MoEs model for diffusions where we can generate media like images for now and of course video eventually. So we'll set this up, and it's extremely easy to work with this amazing framework by Segmind, and we will do this in RunPod, which is a GPU rental provider. I am going to spin up a 800 GPU on RunPod, but you will be able to do it on Colab Pro as well if you have Colab Pro. Now let's jump in and see how we can utilize this amazing framework of that helps you create different experts model.
All right. So to start our experimentation with SegMoE or Segmind mixture of diffusion experts, you can see the GitHub repository over here. We are going to do this experimentation in Jupyter Lab, which is running on a 800 GPU on RunPod. So you can see I am on RunPod right now. You can see it says 1 into 880 GB VRAM, and this is what I've connected using a Jupyter Lab. You'll be able to do it on Colab Pro as well, I guess, so that's not a problem. Now, I will give you a brief overview about SegMoE, which is a framework for creating MoE diffusion models, a mixture of experts diffusion models from, basically it's a framework that helps you also create from scratch. So if you want to create your own mixture of experts from scratch, you can also use SegMoE as well there. Now, it's integrated into Hugging Face ecosystem and supported by diffusers. Okay, it's follow the same architecture as stable diffusion, and like Mixtral ATEC 7B, SegMoE combines multiple models into one. So let me just write something over here. So to make it a bit documentation, so you can also refer to this notebook later. So I'll just write like Mixtral ATEC 7B, SegMoE can combine multiple models into one, and that's what we're gonna look into this. So the way this works is by replacing some feed forward layers with sparse MoE layers. Okay, I hope you would have gone through mergekit and other notebook. There's a lot of blogs which explains that the MoE layer, the mixture of expert layer, includes a network of routers to select which experts handle which tokens most efficiently. Like for example, if there are there are 8 different experts, and when you put a prompt, and then the it basically has a network of different routers, and the router then find out which experts would handle your particular tokens in a most efficient manner. Now, this process will only take, of course, the experimentation will take a few minutes, and you can find out the GitHub repository, which is over here, say MoE, and you can just go install, play around this, and see. We'll see the comparisons and things like that. We'll also try to uh, merge a model. We'll see that. Okay, so here, so far there are, I think, if you come here, there are 3 models which is available, in February first week. One is Sig MoE 2x1, has 2 expert models, 4x2 has 4 experts model, and then ST 4x2 stable diffusion 1.54 1.5 experts model. Now Sig MoE is called, like, of course, AX B. For example, if 2 is A, 1 is B, 4 is A, 2 is B. Now A refers to the number of experts models. So for example, if you have 2, so it means there are 2 models. That's so I hope this gets clear here. And the second number basically refers to the number of experts involved in the generation of each image. Okay. Now, depending on your configuration settings, only some layers of your model, which basically feed forward, block, attention, or all, depending on how you configure it, will be replicated. The remaining parameters are the same as the stable diffuser model that we have been using for so far. Now, there are a lot of samples which are available. You can find out, of course, the right hand side. You can see the best one, the Statue of Liberty next to Washington Monument, and you can see the performance of the model, which is fantastic. uh, let's try and install a few things. So what I'm going to do here is pip install. I'm going to get the updated one to SegMoE MoE, and then we need diffusers, and then we need transformers. Let's install this. Now once we install, it will take a bit of time to install, and then we'll see the image generation using SegMoE 4x2. So what I'm going to do here is, let's create a markdown and say image generation using SegMoE 4x2. Now we'll try this first. So we have to get the pipeline the same way that we used to get it in diffuser. So SegMoE, and then we're going to import. So it suggests, if you're not suggesting, SegMoE should be capital, and then pipeline. Cool, you can see. Now let's get the model. So let's get the 4x2 model. So pipeline equals, and then I'm just gonna get this here, and you can see the class. So sorry. You can see it suggests the class here, and inside this class I'm gonna pass my model. So that model is sig is by Segmind. You can find it on HuggingFace, Segmind, and let me just go up. If you click on this, it takes you over here. So this is what we need. So let me just copy this quickly and paste it over here. And we paste it. So let's bind our device to CUDA because we're gonna use the A100 GPU that we have. Now this will download a few files. That will take a bit of time to do that. Meanwhile, we'll keep on writing our code. Okay, so let's give it a prompt. So I'm gonna write here, what should we write? Cosmic canvas, modern city background, and then let's do painting of let's do painting of a cat. Now this becomes a prompt sample that goes into model, and we can also define some negative prompts. So let me just add that below. So meanwhile, it's loading the model. I'm just going to do negative prompt. Now negative prompt is something that you don't want in your image output. So I'm saying bad quality, blurry, worse quality, and things like that. Let's also get it NSFW. Okay, now this is my negative prompt, and you can see it's running right now. And after that, I'm gonna add a few more here. Now then you use the pipeline that we have created. So pipeline, and in the pipeline I'm gonna pass my prompt equals prompt. So let's do that. And then you pass negative prompt. So negative underscore prompt equals, and then goes negative prompt. and then you get the height of the image. So what would be your height of the expected? Let's get it 1024 x 1024. So we get a good quality image, and we also test the model's ability to generate higher quality images. Width, and then of course how many inference steps, same as the diffusion models. Number of inference steps equals, let's get it like 25, pretty standard. And you can have a guidance scale float value. Guidance scale equals, let's keep it like 10.5. Cool. You can see this still fetching your files. We're almost done with this. Yeah, and then once that is done, now here guidance scale is done, and then we do images and get the first one of this, basically a list. So we get the element of that. Now images, and we can also save that. So what I'm going to do here is img.save image.png, and this will save the image. You can see it's still running. So it gives you a verbose description about the configuration attributes, like the base model, the other important. You can see the loading, it's loading, and now we are almost done with this. And you can see that has been completed. So if you, let's do one thing. After this, what I'm going to add is, let's print the pipeline. Now once you print the pipeline, you can see an object of SegMoE. And now let's get the prompt. Let's get the negative prompt. And now I'm going to run this image, and I'm expecting that it will generate the image for me. You can see we are on A100, which is a pretty fast, so you can get it in like a few seconds, like max at 5 seconds you will get that. And then you save this, and you can see this is the image. This is the image that it has generated. You can see fantastic. I love this image. We'll put it on LinkedIn probably. Let me download this in pictures. I'll replace this. Yeah, this looks good. Wow. Okay, now you can also use local models, to basically you can fetch it locally if you want to do that, but it's pretty much same way. You don't have to change this model path. Right now I have Segmind SegMoE. If you have a local model, you just pass that over here and the rest remains the same. Okay, so I'm not doing that. Now, comparisons can be found on here on the GitHub. If you go back, they have also given over here. You can see the beautiful generated images. Now, it also shows you like how you can create your own like how you can also create your own Sig MoE. Basically, you have to create a config.yaml file. That's what you have to do. So when you have to create a config.yaml file, any number of models basically you can combine there. They have this available on their GitHub repository. You can read that in detail on how to create your own. Okay. Now in that case, you have to first clone the repository, of SegMoE, and then once you run SegMoE config YAML SegMoE the model, it creates a folder that will have a lot of YAML files. You can also do it programmatically. Okay, so let's see it over here. You can see config used to create this model. Okay, this is the config that has used. Comparisons, model descriptions, and I'll go back to the GitHub. Let's come over here. Creating your own model. You can see this is how it says, creating your own model. Okay, now this is all CVIT AI download link, number experts, create a YAML config file, config.yaml with the following structure. Let's just copy this. Okay, and what I'm gonna do is I'm gonna open my VS Code. you can see the base model. What's happening here is there's a base model path, model card, or suite AI download link. Number of experts, you can see it over here. Number of expert, and then it has the MoE layers. Now, MoE layers is where it says type of layers to mix can be FF, attention, or all. So depending on how kind of infra you also have, that is also important, guys, to keep in mind. Then it has number of experts per token, number of experts to use. So how many experts you want to use. Type of the individual models can be HD or HDLs, defaults to HDXL, and then the expert source model, expert one path. So you can keep on adding models over here. And once you do that, you just have to run this command. So I'll just show you how you can run the command and do it. Probably I'll probably not create the model over here, but yeah, I'll just show you that if you change this file path, let's just go back to GitHub. You can see this is the command that you have to run. It's called SegMoE config YAML SegMoE version 0. Once you run this, this will create a folder called SegMoE v with the following structure. So that's what it creates. But you can also do it programmatically. Now I'll show you how you can do it programmatically. If they haven't shown it here, you can see they have also shown it here. Now, if you look at this, it says from SegMoE import SegMoE pipeline, you pass your config YAML device CUDA, and then you save the model as named SegMoE version 0. Okay. Now the model can be pushed to Hugging Face, of course, with that. Okay. This is fantastic, isn't it? Now, let me know if you are merging any one of this with this. Very, very easy. Just have to change this, and once you have that, you just load it over here. Okay, so you save this as config.yaml file. I'll just save it in downloads. You can see config.yaml, and then you upload it over here in your environment. So let me just do that. And once you do config.yaml, you can just run that command now to, or basically you can also do it programmatically from SegMoE import SegMoE pipeline. Or we already have this, we don't have to run this. Now let's create a pipeline merge equals we're just gonna use that class. Okay, and inside this class, I'm gonna pass my config YAML, the file that I have, and then you just bind again the device with CUDA, and then you just have to do pipeline.save. Now it will save locally, and then you can push it to Hugging Face. So save.pretrain, and then you do sig MoE version 1 or something like that. Okay. Now this is how you can save that, but here you have to make all the changes. If you look at the config, the base model path, model card, suite AI download link, and things like that. So all the source model, you can put positive prompt, negative prompt, positive prompt, negative prompt, and things like that, right? So, and this will generate a folder with all your text encoder, tokenizers, unit, VA variational encoders, and things like that. That's what it basically generates over there. Now, let me know if you face any problem while running this in the comment box. We'll be more than happy to help you. Meanwhile, let's try it out and merge our own model. So for that, let's search a few model on Hugging Face. So let's go on Hugging Face. We'll select a base model. We'll select some, experts model. I look more animation kind of a thing. So here, maybe we're gonna go with, let's use real wage. So I'm searching for, you can see, yeah, right. So let's use the version 3.0, probably turbo. Or should we, yeah, I think it's important. The model is still in the training phase. Okay, let's go to SG161 and see which model we can use. Not probably the turbo, but Excel version 3, we can use that. So maybe we can use real wage XI, maybe this. Yeah, let's use this as base model. So how we're gonna do is we're gonna define this here, base model, and let's write that here. Now this becomes my base model, and number of experts. So I'm gonna use, for example, let's have 3, as experts model. So three more and MoE layers, so type of layers to mix. I'm gonna go with all for now. So let's use all. So I'm writing all, and then it says number experts per token. So number of experts to use. Let's use 2, and type of, or let's increase the number of experts to 4, and the type of individual models HD, HDXL, default to HDXL, so let's keep it HDXL as default. Now, in the experts, we're gonna choose some models. So let me search a few models. Let's search. So where is Frank Joshua? Yes. So I'm gonna use a few models from Frank Joshua and the other model that I have selected. So we're gonna use these juggernaut models. Okay, so let me just go inside first this. So Joshua Frank, if you don't know, he's a great guy. He's strengthening the open source community. You can see more than 60 models. Now, from Joshua Frank, I'm gonna use a few model from here. Let's see which one we can select. So, for example, we can get this as one. It has many downloads. I'm gonna copy this. Let's come here on the config, and in the source model you're gonna put this as it is. So let's just put that, and in the positive prompt, again, now here it needs to be defined. So positive prompt, let's write like, I need cinematic, I need realistic, I need portrait, things like that. Right now you write hyper detailed, and whatever you can basically enhance that, right? And aesthetics. So for example, I'm going to go with this much, and you can keep on increasing it, by the way. And these are the positive prompts that I'm going to rely on. Negative prompt, I'm going to say, and in negative prompt you have to define this way. So let's write worst quality, low quality. I don't need low quality in my image. Normal quality, low details, blurry, overexposed, and things like that. Right now, let's this becomes one part of it. You can keep on, you can also keep other. Now you can keep on creating separations. Basically, in this string you can define different things as well. So for example, this becomes my one set, okay, where I'm looking at. The other set can be of watermark, signature, and things like that. So let's just do that. So I'm going to do watermark, I'm going to do signature, uh, username, error, etc. Right? You can keep on increasing this if you want. Yeah, but this is what it is. Okay, now this is fine. Let's use the other one, the other source model. So the other source model can be, let me just remove this here. So we can use, what could be the other source model that we should use? Okay, so I think this, even if you can also use the base model as a, of course, as a source model. So let's do that. Uh, Real Excel version 3, and then I'm going to copy the same thing, but I'll just make a few changes here. So let's just copy, put that in positive prompt. Let me just do that. Cinematic realistic, let's put it like fashion. We're gonna do 8K. Let's call it ultra realistic. Yeah, this will be good enough for positive prompt. In the negative prompt, let's copy the same thingy. Now I'm just going to copy this entire thing here, paste it. Well, this needs to go in a string, so let me just put that here. Now let's call it for this model, negative prompt can be bad photo, and sometimes it generate anime, so let's don't need an anime for this, so it's fine. Now the third source model, so let me just remove that. let's get some animations model and see if it's able to derive that. So there is the any imagine Excel. Let me find it out, that model here. So what I'm gonna do is uh, it's not opening. Meanwhile, I will just go here and I'll search any imagine Excel 3 point not hugging face and see if, yeah, by yes, correct, that's the model I want to prefer for this. So let me just copy here that model and you may imagine, and for here I'm just going to put my you know the again the positive prompt and the negative prompt. So let me just put that over here. Now I'll just copy this again, copy paste, you can keep it things like anime. I'm gonna put anime, painting, painting, PANTING, and the rest looks nice. I'll remove fashion from here. You have to do a bit of bit of engineering with the prompt here. That how do you select a prompt for both positive and negative? But I'm just gonna copy this here. So let me just copy and paste, and I'll say that I think this is fine. But so let's keep that as it is. And not required that you always have to put this here. So let me just show you what I'm telling you. You can keep it like this as well. Okay, so it's not always required that you put things in a thing. Now the last model, let's get it. Let's go to Frank again. So I'm gonna search here. Frank. Yeah, let's come here and see which model we can take. Any other Excel model by Joshua Frank, uh, which we can take it. Uh, hmm, there's many models. Albedo Excel. Okay, Albedo base Excel. Let's take this model. That's what it is. And for this positive prompt, let's copy it from here. Control C, Control V, and then I've also put the negative prompt from here. So let's put the negative prompt. Negative prompt is something that you don't want to see. So I'm gonna call it here few changes. So let's make a few changes. Call it like bad hands, bad fingers, and missing fingers, and things like that, right? And then it can go unedited. Can remove anime here, unedited, and I'm gonna call it raw, and we can call it photograph, and I'm going to remove painting from here. So let's remove the painting now. So this is what we have, guys. So let me just do a control S, so it saves the config YAML. Now let's try it out. So if you open the config YAML, you will see that these are the changes we have made. Base model, number of experts, MoE layers is all, number experts per token 2. So you're gonna get a 4x2 and type HDXL. These are the model we have selected. Two models from Frank Joshua, one from Caglio Istrolab, and the other is from stable SG161, which is stability. So what I'm gonna do is go to SegMoE, and I'm trying to, let's run this and see what happens. And I will just run this first and see what happens. And if you get any error, you have to again do a trial and error, because not probably not all the model, of course not all the model supports this, so you have to change the model, source model, and see if that is the problem in your case. But yeah, so you can see once this is done, it will generate some uh, folder that will have like whatever name that you have given, that will generate the folder. And you can also do it programmatically. So let's wait for it first and see what it does. And if you get a CUDA out of memory error, you can see that I am getting, it says no space left on device, because I have a CUDA problem here. So that's the problem that I am facing. Now I have to increase the left. I don't have space left, but I'll just show you how you can push this after doing it. So that was pipeline. First I have to save that, pipeline.save pre-trained, and then you save it over Sig MoE and version not, or whatever version you want to give, you can give it. Let's see. I have I don't have much space on this run pod that I'm utilizing, and that's why I got the error, but it is fine. And once you run this, you'll be able to push it. And how you and you can just once you push this, you can also try it locally, to generate the model. So you can push it on Hugging Face. If you don't know how to do that, let me just write that for you. There are two ways you can do it. You can do it through Hugging Face Hub notebook login, and then you can push it. You can also do it Hugging Face CLI. So what you have to do is you have to do Hugging Face CLI, and then you have to not this would be not be space, I guess. Hugging Face CLI, and then you click upload Segmind, and then you give Seg whatever is your username and things, you can put it. But this is for the Segmind, so you can, for my case it's SQMA307, and then you can put it on the model Sig MoE version node, and then you can do dot slash blah 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 Sig MoE version 0. That's how you can do it. So this is how you do that, and then model can be pushed. Of course, you can do it programmatically also, and yes, and then you can use that. Okay, so you need a basically high virtual RAM. Just for your information, you know, inference is very fast as you saw, but it still requires large amounts of virtual RAM, and therefore expensive GPUs, and this makes it difficult to use locally. But for reference, 4x2 requires 24 GB of VRAM at half precision. But we already have loaded the model, and we are trying to load so many other models and then bind it together. That's the problem. So after getting the no space left on device error, what I did, I made a bit of changes in the config YAML and reduced the source model from 4 to 2, and I made a 2x1 model. Okay, because I had not that much of space, with the VRAM and things like that. So you can see the expert prompts, and expert prompts was completed, and then I saved the pre-trained over here. You can see the folder had been saved over here. That's called Sig MoE version 0, and it contains everything that you need to load and inference this. The same can be pushed to Hugging Face as well. I have shown that previously before the error, that how you can do it with Hugging Face CLI. Now this ends our experimentation with Sig MoE, guys. If you have any question, thoughts, please let me know in the comment box. This notebook will be available on my GitHub repository as well.
That's all for this video, guys. Now I hope you have basic understanding of how you can use this framework, SegMoE, and can create your own mixture of expert model. And I'll share the this GitHub repository, the Hugging Face repos of all these models, and also the blog that can help you look at and how you can create it. And I will also share you a config sample, config.yaml, that will help you just replace the models and the positive and negative prompts, and you will be able to create your own diffusion MOEs model. If you have any questions, thoughts, or feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. Those informations are available on channel banner and channel about us. If you like the content I'm creating, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel. Thank you so much for watching. See you in the next one.